Hello everybody, this is the notes for section 1.6 for geometry. What we're talking about here is polygons, and so first thing we got to do is define what a polygon is. Basically, triangles, rectangles, squares, pentagons, octagons. Those are polygons. Those are common examples of polygons. But just some of the terminology, some of the little fine details about it, like it says, a polygon is, and as a reminder, you might want to hit pause, copy down some of this information, but a polygon is a closed plane figure with the following properties. So a closed plane figure, what that means is it's on the same plane. All right, so you're not going to have a polygon that is one side of a shoebox and then a different side of the shoebox, because that's two different planes. So a polygon is going to be all on one surface. All right, the idea of closed is, yeah, there's three sides there, but you're not going to have this be called a triangle because, well, it's open. You can get to the inside. All right, that's what they mean by a closed plane figure. All the segments meet at each other's endpoints, and that's kind of what it says here in number 2. Each side intersects exactly two sides, one at each endpoint. So the other thing is if you have this segment and then you have another segment meeting at the same endpoint, what you're not going to have is this. With those three segments, the red, blue, and green ones, that's not going to be a triangle because they're not meeting each other at their endpoints. So if I were to get rid of this green one, whoops, and put it at this endpoint to this endpoint, now you got a triangle. All right. So just that's some of the little details. I mean, you know what a polygon looks like and deals with, but some of the finer details. Each endpoint of a side is called a vertex. So the other thing we got to talk about is naming a polygon. Really what you're going to do is pick a point, okay? Just with this polygon that's up here, I'm going to start at point A, and when you name a polygon, you just go around the shape. You start at one point, go until you got all the vertices. So this would be polygon A, B, C, D, E. Just go around side to side, point to point, like it's a connect the dots. Don't start skipping around, going from this point to that point, and then skipping around to the other side. Just go in order. The order doesn't matter. If we wanted to start at E and go the other direction, E, D, C, B, A is a fine way to call this polygon. Just pick a point and go around the shape. All right. So, some other terminologies, convex and concave. Again, go ahead, hit pause. You can copy some of the details down here. But basically the idea of concave. Look at this picture on the rightmost of your screen. This is a concave polygon because you can draw a segment connecting vertex to vertex, and that segment is on the outside of the shape. All right, if you can do that, if you can draw that segment from one vertex to another vertex, okay, anywhere on the shape, if you can draw that segment and it's outside of the polygon, it's concave. Okay, if you can't do that, then it's called convex. All right, I think most of you know most of these, but I do want you to know all of these things. 3 sides, you got a triangle, quadrilaterals, 4 sides. Pentagon, hexagon, those are kind of common ones. A heptagon is 7 sides. That's not very common, but I do want you to know this. Same thing, octagon, you should know that's 8 sides. Nonagon, 9 sides. Decagon is 10. Dodecagon is 12 sides. There's not really a name for an 11-sided polygon, but what we would call it is an 11gon, okay? There are certain names, like it says here in this chart, for a certain number of sides, but anything different number of sides, you just call it that many sides, gon. Okay, 11gon. Down on the bottom here, very important names. Equilateral. Okay, lateral is, one of the definitions of lateral is to the side, or sides. So, equilateral means equal sides. Okay, so if you have an equilateral polygon, all the sides are exactly the same length. Equiangular is just that, equal angles. Okay, if a polygon has all the same angles, it's equal angular, like a rectangle. A rectangle has 4 90-degree angles, so it's equal angular. But a rectangle has different side lengths. You know, the opposite sides are the same, but not all of the sides are congruent to each other. So a rectangle would be equal angular, but it's not equilateral. And then the last one here is a regular polygon. A regular polygon is equilateral and equal angular. So all the sides are the same and all the angles are equal to each other. Okay, need to know those terminologies. All right, I would like you to hit pause and give these examples a try. All right, I hope it went well. It says, tell whether the figure is a polygon. If it is not, explain why. If it is a polygon, tell whether it is convex or concave. All right, a polygon, it's formed by segments. So when you look at number 1, you got these curves right here. This is not a polygon, just because of the curves. Number 2, that is a polygon. It's all segments. Also wants to know if this convex or concave. Remember, you can connect 2 vertices. If that segment is outside of the shape, that is concave. So number 2 is. It is a polygon, but it's concave. Number 3, all the segments that are meeting at each other's endpoints, that's a polygon. This one, any 2 vertices you try to connect, that segment is going to be inside of the shape. This would be convex. All right, looking at example number 4, it says classify the polygon by the number of sides. So 1, 2, 3, 4, 5. Okay, I'm putting these tick marks just to count, not to say that they're equal. I mean, they are because they're all 3 meters, but just me counting. So 5 sides, that's a pentagon. Also wants to know, is this equilateral, equal angular, or regular? So all 5 sides are 3 meters, so it's equilateral. And these little arcs right here are saying all the angles are congruent to each other. So it's equal angular. When it's both, that's a regular polygon. Okay, so this is a regular pentagon. Looking at number 5, there's 4 sides, so it's a quadrilateral. Now this is a specific type of quadrilateral. It's called a rhombus. We'll get to that eventually. But all 4 sides are equal, so it's equilateral. But one arc, those 2 angles are equal to each other. Double arcs, top and bottom here, those 2 angles are equal. So all 4 angles are not equal to each other, so it's not equal angular, which means it's not going to be regular, so it's just. It's equilateral. All right, number 6, triangle. It's not equilateral, it's not equal angular. That one's actually called an isosceles triangle. We'll talk about that later again. Looking at number 7, all 6 sides. So it's a hexagon, but all 6 sides are not the same. These 4 sides are congruent to each other, but then those sides with the double tick marks, they're different, but they're congruent to each other. So all 6 sides are not the same, so it's not equilateral, which means it's not going to be regular. And all the angles are not the same. We have 4 congruent angles, but the other 2, here and here, they're not equal to the other one. So it's not equal angular, it's not equilateral, it's not regular, it's none of those. And for our last example, again, I would like you to hit pause, try this on your own, see what you can come up with, and then listen to the explanation and see it work through. Okay, so the expressions 6x minus 4 and 4x plus 2 represent the lengths in feet of 2 sides of a regular pentagon. Find the length of a side of the pentagon. Key thing right here, it is a regular pentagon, so all the sides are the same. Here are 2 expressions for 2 of those sides. So, because it's a regular pentagon, these 2 side lengths are equal to each other. And that's how we're going to get our answer, by setting these expressions equal to each other. And now it's just a matter of solving for x. So I'm going to subtract 4x from both sides. I'm going to add this 4 to both sides. So I got a 2x equal to a 6. X is 3, but I have to pay attention to the question. It says find the length of a side of the pentagon, okay? X is not a side length, it's just a variable. So what we need to do is take this x value and plug it into one of these expressions. I just chose that second one for no good reason. But 4x plus 2, x is 3, so we got 4 times 3 plus 2, that's 12 plus 2, which is 14. There is a side length. Okay. That is it for these notes. Have a good day. See you in class tomorrow.